All right, folks, it's Bass Action, back in action here. In this video, we're going to go through two things. On the top part of this video, we're going to go through how we can bring together our ideas of special right triangles and Pythagorean theorem within the coordinate plane. It's going to be just a very, very basic introduction to something that you'll see in a couple years when you get to pre-calc. And then on the bottom, we're going to introduce a definition of angles of elevation and depression, and you'll be working on some word problems related to this and applying this concept later. So let's jump in here on the top, and the first thing I want to call your attention to is this note over here to the side. As we work through these three examples, it's important for you to know that the x and the y coordinates that we're going to be solving for can be positive or negative. The x and y coordinates are simply going to be based on a movement within the coordinate plane, whether you're moving positive or negative on the x-axis, positive or negative on the y-axis. The radius of the circle, we're going to have a circle drawn in each time. That radius of the circle will also be the hypotenuse of a triangle, and that radius must always be positive. So even when we're going to get down here, for example, just thinking ahead to this problem number 2, even though our hypotenuse, our radius of our circle is going to be below the x-axis, that has to remain a positive number. And that's because the radius of a circle by definition is going to be a distance, and distance has to be positive. So the x and y are going to be movements in the coordinate plane. The radius is always going to be a distance and will have to be kept as positive. Now, beyond that, we're just going to apply Pythagorean theorem and then our two special right triangles. This first problem we've seen before. We've seen this one before, and we're going to look at this little right triangle here. And the first thing that we want to notice is that the radius of the circle is 50. So this 50 applies to this segment right here, but it also applies to this segment right here, even though sometimes our eyes don't want to believe that it's actually the same. So what we're going to do is just a quick little Pythagorean theorem using this 14. That means we went over 14 and up some length y. So the 14 goes here. Now you've done this problem before. We've got a 50 squared, then we've got our 14 squared plus our y squared. Our quick Pythagorean theorem is going to get us y equals the square root of 2,304. And although this might not pop out to you as a perfect square, if you just quick hit your square root button, you're going to find that our y value is 48. Since our y is above the x-axis, we're going to keep that as a positive number. Now, moving on to this next one, this is going to be a more advanced problem. When we move on to this next one, notice that the triangle is not all drawn in for us. So what we're going to indicate is that this number of degrees right here is 315 degrees. Well, we understand that the circle has to be 360 degrees, so we know that this angle right here, this remaining angle right here, has to be 45 degrees. What we want to do is we want to turn this into a triangle similar to what we had up above. So we're going to draw in a perpendicular, and we're going to make sure that the right angle is on the x-axis. So we're going to create this new little triangle right here. We've got a little triangle that now we've made, a little right triangle. And again, I gave you that the radius is 20. So if the radius is 20 here, the radius is going to be 20 here. And remember, the radius has to be positive. So I'm going to put my 20 right there. Now what I can see is that the triangle that I have here, this little triangle, is a 45, 45, 90 triangle. If that's 90, this is 45, and that's 45. So I'm going to look for my x and the y coordinates. I know that the legs of this 45, 45, 90 triangle have to be the same. If I'm remembering my extended ratio, I'm starting here on the hypotenuse, and I need to go backwards to the legs. So I'm going to take my 20, I'm going to divide by the square root of 2. I'm going to quick rationalize this. So I get 20 radical 2 over 2, and of course I reduce that to a 10 radical 2. Now that I have my two numbers, 10 radical 2, for both of them, I need to decide which one should be positive and which should be negative. So when I look at this x and y, to get to this point, I would go over a positive amount and down a negative amount. So I'm going to say x is a positive 10 radical 2, but y is going to be a negative 10 radical 2. Okay, now let's look at the next one. Again, I don't have a triangle drawn in, but I do have an angle measure right here. So I've got this angle measure of 150, which means this little angle that's left over right here has to be 30 degrees to get me to half the circle is 180. Then I'm going to turn this into a little triangle. Again, I'm going to draw on a perpendicular, putting the right angle on the x-axis. That's very important. Then we're going to highlight our little triangle. So this is the little triangle we're working with. Sometimes students even like to redraw this little triangle. They like to redraw it maybe over here to the side so that they can pull it out and make it a little bit easier for them to see, separate from all the other stuff. What we can see here is what you were given is a -6. So that's going to be this segment right here is going to be -6. So I'm going to have a -6. Remember that negative really only applies to the fact that it moved in the negative direction. Now I'm going to look at my extended ratio, this 1 radical 3, 2. When I look at this 30, 60, 90 triangle, I can see that I'm starting with the long leg. So on my extended ratio, I'm starting here at the radical 3, and I need to go backwards to the short. So I'm going to take that 6, and I'm going to use a positive 6 and not a -6. I'm going to take my 6, I'm going to divide by my radical 3. I'm going to rationalize again. Again, you might be able to do this in your head, and that's okay if you can. Go for it. That's going to get me a 2 radical 3, and that's going to get me to the short leg. So now I can see that this is my short leg right here. So that means that the y coordinate is 2 radical 3. I just realized I wrote a 2 there and not a 3. Let me fix that. 2 radical 3. There we go. Okay, so the y coordinate is 2 radical 3. Now that I have my 2 radical 3, I'm now at the short, and I need to go all the way to the hypotenuse. So now I'm just going to multiply by 2. So that's going to get a 4 radical 3 right here. So my x, that's this x right here, is 4 radical 3. Make sure that you didn't copy down that 2 that I wrote earlier, because I was just a little righto, just got ahead of myself and I wrote a 2 instead. Okay, so that's all that we're going to do with these. You're going to do some Canvas problems like this and just practice these. Now let's take a look at angles of elevation and depression. All right, we're going to do a whole bunch of trig word problems related to elevation and depression, and this part's going to be pretty quick. What we're going to imagine is that if we have a person that's standing on top of the building, okay, so they're going to be standing up here, and they look down to the a car down here at the ground. So they're going to look down. This is going to be their line of sight. As they look down, the angle that's formed between this line of sight and a horizontal line, this is called the angle of depression. If, however, our person is standing down on the ground and they're going to look up to the top of the building, they're going to create a line of sight. The angle that's formed between their line of sight and the horizontal, it's usually the ground, that's going to be called our angle of elevation. Now, a couple things to be reminded about. If the problem does not mention how tall the person is, then you can essentially assume that their eyes are on the ground. What it's simply saying is that their height is immaterial to the problem, so we can ignore it. If it mentions the height of the problem, height of the person, you will need to add that in. Now, more often than not, for an angle of depression, you are going to have to draw in this horizontal line. Sometimes you will have to draw in the horizontal line for an angle of elevation, in particular when they mention the height of the person. So sometimes you'll have to draw this in. The most important thing that you want to know, and I want you to recognize here, is that angles of elevation or angles of depression, when we draw in this horizontal here, and it's between the line of sight, I want you to notice that the angle of depression is outside this triangle that we have here. So you could either take the angle of depression and find its measure on the inside of the triangle. It's a complement. But even easier than that would be to recognize that this horizontal line and the ground are parallel, so we have a transversal. We have parallel lines cut by a transversal, so an angle of depression will be congruent to the angle of elevation down below. And more often than not, that's what I would really encourage you to do, is to take that angle of depression and rewrite it as the elevation down on the ground.